This is Dr. M. Satyanarayana Gupta, Professor and HOD of Department of Aeronautical Engineering, MLR Institute of Technology, Hyderabad. In this semester, I am going to be teach finite element method. So before going to the in-depth of finite element method, today I will discuss the introduction to the finite element method. So in this introduction slide, I am going to be discuss with the introduction of the finite element method. Then I'm going to be discuss methods of engineering analysis. Then what is the FEM procedure? How we can FEM is a tool. How can apply this FEM to the different domains that I will discuss. Then I will discuss advantages FEM. So before going to the in-depth of the finite element method, what is the advantages FEM? Where we can apply the FEM, that I will discuss. Next is a disadvantages FEM. What is the main disadvantage of the FEM? So that I will discuss today. Then applications of the FEM. Once you know the what is the procedure of the FEM, then we can see the applications of the FEM. That means where we can apply the finite element method. Next, we will discuss the course outcome. So at the end of this course, what actually the learner will learn, what the learner will do, all these things we can discuss in the course outcomes. So coming to the first one is, and next one is what textbooks we can use for the finite element method, or what textbook are used for this one, that we will discuss in the last slide. Finite element procedure, then we can see that advantages of the finite element method. The main advantage of the finite element method is the finite element method solve the complex analysis very easily. So I already said that the finite element method is used for the only for complex analysis. We never use the finite element method for the simple analysis. For simple analysis, the conventional approach is a better than finite element method. And next one is say it is a very flexible. We are using the computer, and because of that one, it is a very flexible. Suppose at the end of our analysis, we see that the induced stress is more than the yield strength, then our component will be failed. Then simply you can change the geometry of the what is called geometry steps, geometry of the given domain. Then simply it will change the what is called the total analysis, and finally it will give the results. And because of that one, it is a very flexible. Next one, it will handle the non-linear behavior. See, the analysis of non-linear analysis is a very complex, very complicated. So the finite element method, easily we can analyze the non-linear behavior. Next one is the another, see, handle the complex analysis types. So vibrations, heat transfer, fluids, etc. Easily we can analyze using the finite element method. And next is temperature dependent properties like creep, etc. also we can analyze using the finite element method easily. And one more complex analysis is a what is called non-homogeneous and non-isotropic. The analysis of this non-homogeneous, non-isotropic is a very difficult, but using the finite element method, very easily we can solve the what is called this non-homogeneous and non-isotropic materials. And see, that means it's a very easy to analyze the composite components. Composite is a non-homogeneous and non-isotropic material. Mathematically, it is a very difficult to analyze the composite components, but using the finite element method is a very easy to analyze the composite materials. I already said that it is also used that temperature dependent properties like the creep and plasticity, everything easily you can deal with the using the finite element method. So I said that the finite element method is a tool. This can be applied to the any type of analysis or any type of domains. And next is it will solve the complex boundary conditions, and it will be reduce the prototypes. So before testing the prototype, using the simulation, we can see that the designed component is safe or not safe, and it will reduce, because of that it will reduce the what is called prototype testing. The prototype testing is a very costly process, but using the finite element method, we can reduce the prototype testing. Compulsory prototype testing is required, but the number of prototype testings will be reduced using the finite element method. Next, coming to the disadvantage. I already said that the main disadvantage of the finite element method is it will not give the, otherwise it will not provide the exact solution. It will provide the approximate solution, but it is accepted solution. So it will give the what is called closer to the exact solution, but it will not give the exact solution, but it is accepted by the all industries. So it will not give the exact solution. It will produce the approximate solution. Because of that one, prototype testing is mandatory, but it will reduce the number of prototypes. It will reduce the number of prototypes. Prototype testing. So finite element method is a time consuming process. It is a very lengthy process, but once you can develop the what is called the programming for that one, then it will be very flexible, very easy. First, initially it is a time consuming process and it will require the very high mathematical knowledge, and need to depend on a powerful computer. Already I said that it is a very complicated process, and because of that one, and it is not a complicated, it is a very lengthy process. Why? Because we have to apply the step by step procedure, and because of that one, it is a very lengthy procedure. Sometimes we can use the even 1000, 2000, 5000 elements. It is a very difficult to what is called develop the 1000 elemental equation manually. It is a very difficult, and because of that one, we depend on the a powerful computer and a reliable software. And next one is say requires sound background in mathematics. So it requires what is called mathematical. Any engineering analysis compulsory require the mathematical background and physics background also. Next is application. What not? In any field, we can apply the finite element method. Suppose say it can apply for the aeronautical engineering to analyze to do the what is called structural analysis or stress analysis of all aircraft parts or spacecraft parts. We can use the we can use the finite element method. Even to find the frequencies and mode shapes of all parts of the aeroplane, we can use the what is called finite element method. Similarly, the mechanical engineering also. To find the structural analysis of all components of the automobile or any machinery, we use the finite element method. And similarly, dynamic analysis also, we can use the what is called the finite element method. And this also used in the civil engineering to analyze the beams, to analyze the frames, to analyze the trusses, to analyze the bridges. But in all these cases, we use this what is called finite element method. And even it is used in the nuclear engineering. So this is also used to analyze the pressure vessels also, reactors, pressure vessels, etc. So it will be used in different domains. In all engineering is accepted. The finite element method is accepted by the all engineering fields. So for example, say aeronautical engineering. Already I said that the static analysis of aircraft wings, fuselages, and say rockets, spacecrafts, and missile structures, we use the finite element method. And dynamic analysis of the aircraft also, we can use the what is called finite element method. That means to find the natural frequency, to find the flutter and stability of aircraft, rocket, spacecrafts. For all these things, we can apply the finite element method. Coming to the mechanical engineering. So stress analysis of pressure vessels, pistons, and composite materials, gates, etc. We can use the finite element method. Similarly, to find the natural frequency and stability of the linkages, gates, etc., we can use the finite element method. So civil engineering also, static analysis of trusses, frames, roofs, shear walls, we can use the finite element method. And natural frequency and mode shapes also, we can use the finite element method. That means the finite element method is used for the static analysis and dynamic analysis of the aeronautical engineering, mechanical engineering, even civil engineering, and even nuclear engineering also, we can use the finite element method. So in analysis of nuclear pressure vessels and steady state temperature distribution, that means thermal analysis also, we can use the finite element method. And coming to the another domain, so heat transfer, thermal analysis. For thermal analysis also, we can use the finite element method to know the temperature distribution in the IC engines, the temperature distribution in the jet engines. In all these cases, we can use the finite element method. And even it will be used in the steady state analysis, even transient analysis also, we can use the heat transfer. Steady state analysis means temperature is a constant with time. The transient analysis means the temperature varies with time. So both the analysis, we can use the finite element method. The next one is a electrical engineering to find the eddy current, and we can use the what is called electrical, we can use the finite element method. And coming to the biomedical engineering also, we use the finite element method. So to analyze the what is called teeth, or to analyze the implants, all etc., we can use the finite element method. Suppose say it is the heat transfer. So steady state temperature distribution in the solids as well as fluids, we can use the finite element method. I already said that steady state means the temperature is constant with time, and it is also used in the transient heat flow in the rocket nozzles, IC engines, turbine blades, etc. So transient heat transfer means the temperature is variable or changes with the time period. So for steady state as well as transient heat transfer, we can use the finite element method. And coming to the electrical engineering, so steady state analysis of the induction machines or eddy current, etc., we can use the finite element method. Coming to this, so nowadays the finite element method is usually using in the biomedical engineering. So in biomedical engineering, suppose say analysis of eyeballs, analysis of bones and teeth, and analysis of the implant, etc., the finite people are using the finite element method. So by seeing this application, I can say that all engineers are accepting the finite element method. So I already said that it is a tool, it can applied for the multidisciplinary. Any discipline, we can apply the finite element method. And because of that one, today all industries are using the finite element method as a powerful tool for the complex analysis. I already said that for easy analysis, we won't use finite element method. Only complex analysis, we can use the what is called finite element method. The complex means, already I said that the complex means it may be a complex boundary condition, it may be a complex material properties, it may be a complex geometry, it may be a complex properties also. So in all the cases, we can use the finite element method. Next is at the end of this course, the student should be able to develop elastic equations, formulate and solve the axially loaded war structures using the finite element method. And what is the next is the students should able to apply the finite element method for the truss and beam analysis. And third outcome is the students is able to implement the finite element method to solve the two-dimensional problems. Third one is the students is able to solve and analyze the heat transfer problems. The last outcome is the students are able to apply the finite element method in the dynamic analysis. That means the students are able to find the frequencies and mode shapes using the finite element method. So at the end of the course, the student will learn these 5 outcomes. And coming to the textbook, so Introduction to the Finite Element in Engineering by Tirupati Reddy in Chandraputla is a one good textbook. And second one is a Introduction to the Finite Element in Engineering, Jalaluddin. These two books are very good for the what is called beginners. And thank you.